Hello and welcome to part 5 of the trigonometric series I'm doing. In this video, we're gonna be solving some questions regarding the ASTC rule, and I'm gonna be showing you practically how to use it to solve trigonometric equations. So let's get into it. For the first equation, we have something that tells me solve this trig equation. This trig equation goes by sine x equals a half for this range, and I can see that my range is in degrees, so I'll make sure that my calculator is set to degrees for me to solve. Okay, so as we spoke in the last video, since sine, cosine, and tan are repeating and cyclic functions, you can have multiple answers for the same y value. Okay, so let's see how we can get all the values within this range that satisfy this equation. First of all, we start by getting the base angle or the base answer. Okay, this is by doing arc sine or sine to the power of -1 of half. This, when I put in my calculator, is going to give me 30 degrees. Okay, so this is my first answer. So let's draw our ASTC quadrants and see how we're gonna move from there. So this is my X, this is my Y. I know that this quadrant is A, S, T, C. A is all, S is sine, T is tan, C is cosine. And then the next step is writing my angles. So I know that this is 0 degrees, this is 90 degrees, 180 degrees, 270 degrees, and this comes to a full circle, which gives me 360 degrees. From here, the second and the next step is to look at my answer. I want my answer to be positive, so I want sine of something to give me a positive answer. So I know that sine is positive in the all quadrant and in the sine quadrant. So I will draw my two lines in those quadrants. And I'm going to start from the positive x direction, going anti-clockwise as a positive and clockwise as negative. So my first angle is 30 degrees. That's my first angle, my first answer. So I'm going to go from the horizontal x direction. I'm going to go 30 degrees clockwise. This is my first angle. To get the second angle, I will also start from the positive x direction, and I'm going to move until I hit my next line, and I need to calculate this angle. So I know that by symmetry, this here must be 30 degrees, and this here must be 60 degrees. So this whole angle is basically my 90 degrees plus 60. So the next answer is 90 plus 60, which is going to give me 150 degrees. So up until now, I have 30 degrees and I have 150 degrees, and they're both inside the range. Let's see if we have another answer. So to get the third answer, I will need to also start. I'll always start from my positive x. I'm going to move clockwise until I hit the next line, which is this line. And by doing this, I can see that I've done a full rotation. So up until here, that's 360 degrees. And then I added 30. So this angle right here is 390 degrees. If I put in my calculator 390 degrees, so sine of 390 degrees, that's going to give me a half. So this must be correct. However, this 390 is outside of my range, so I will neglect this answer and I will only take these two answers. So let's take another example to further illustrate this. Okay, let's take this example for instance. Okay, this question says, solve the equation tan of x equals 2 for 0 to 360. I'm working in degrees, so I'll make sure my calculator is in degrees. Again, I will get the base angle, arctan of 2, or tan power -1, or tan inverse of 2. This is going to give me an angle of around 63.4 degrees. So this is my base angle. Next step is to draw my ASTC quadrants. So this is my x, y, this is 0, 90, 180, 270. These are all degrees, and this is 360 degrees. Okay, I know that this is my all, this is my sine, this is my tan, this is my cosine. So after drawing this in degrees, the next step is to look at my answer. I need tan of something to give me 2, and I know that 2 is a positive answer. So I want tan of an angle to give me a positive answer. So at the end, I will want my tan to give me positive. So I will draw my lines in the quadrants where tan is positive. So I know that tan is going to be positive in the all angle, all quadrant. Let's draw it like this. And it's going to be positive in the tan quadrant as well. So these are my two lines. Now I'll start with my base angle. I know that this side is positive, so anti-clockwise positive, clockwise is negative. So I'm going to start from my positive x, moving clockwise 63.4 degrees. This is my first answer. To get the second answer, I'm going to also start from my positive x. I'm going to move anti-clockwise until I hit my next line. So I know that if this is 63.4, this is also 63.4 because they're vertically opposite angles. So this angle, this big angle that I'm trying to find is basically 180 plus this 63.4. So it's going to be 180 plus 63.4. This is going to give me an answer of 180 plus 60, yes, 243.4 degrees. And I know to get the next answer, I will need to start from here, going all this way, and then exceeding 360. So I'm not going to take this as an answer. So these two will be my answers. And if you want to check, you can put on your calculator right now, tan of 63.4, and you put tan of 243.4. And to check, they both should give you an answer of 2, and checking this is correct. Obviously we did some rounding, so it's going to give you an answer of like 1.99, but if we took the exact thing, it's going to give you 2. So these are our correct answers. Okay, let's move on to this question. Okay, this is a little different. So we have a negative answer now. So again, I have a cosine theta equals negative 0.9 for this degrees. So I know I'm working with degrees. So again, we're going to start by finding the base angle, which is cosine inverse of negative 0.9. This is going to give me 154.16 degrees. Okay, so next step, drawing the ASTC quadrants. So let me do that. I have an x, I have a y. This is 0, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. I know that this is positive, this is negative. I have my ASTC. Okay, looking at the question, I need a cosine of an angle that will give me a negative answer, and I know cosine gives negative answers in which quadrants. So cosine gives a positive answer here and a positive answer here. So that means that it gives a negative answer in this quadrant and in this quadrant. So let's start with the base angle. I always start with my positive x side. I will move 154 anti-clockwise because it's a positive angle. So I will move, and I will know that this whole angle is 154.16 degrees. And this angle is basically 180 minus 154.16 because this is a straight line. This is going to give me an angle of around 25.84 degrees. Okay, so let's start by getting our next answer. So I will also start from the positive x degrees, go anti-clockwise until I hit the next line. Okay, so by symmetry, if this angle is 25.4, this angle is also 25.84 degrees. So the angle I'm trying to find is going to be basically a 180, this straight line, plus this 25.84 angle. So it's going to be a 180 plus 25.84. This is going to equal 205.84 degrees. Okay, so I know that if I want to get the third angle, I need to go this full rotation, which is 360, and then exceed it to get to the other part. So this is out of my range, so I will just keep those two answers, and this is the answer to my question. Okay, let's take another example. Let's say we have an equation that's a little different. 2 sine, 2 theta now. And we've always dealt with sine theta, cosine theta, but never with something that is multiplied or altered inside the theta. So let's see. Now I know that my range is in radians, so I'm going to change the angles in my calculator to radians, and let's start solving. So I have a 2 sine 2 theta equals 1. Okay, I will divide both sides by 2, so I'll have a sine 2 theta equals a half. Okay, so from here, I don't like to work with 2 theta inside. I always like to work with a single, with just one letter, one variable. Okay, so I will say I will let capital X equal my 2 theta. So now I will have sine, instead of 2 theta, I'll have a capital X. This is nothing just, it's like renaming this 2 theta as X. That's the same exact thing, equals half. Okay, and let's see what we will do for our range. So we have this range over here, but we're not working with theta, we're working with 2 theta. So we need to make this part in the middle 2 theta. And in order to do this, I will need to multiply the middle part by 2. And whatever I do to the middle part, I need to do the same for the left part. So I'll multiply by 2 here, and to the right part as well. So I'll multiply by 2. So 2 times 0 is 0, less than or equal. Now I have 2 times theta is 2 theta, less than or equal 2 pi times 2 is 4 pi. So this is my new range. And I know from here that x, capital X is 2 theta, so I can rewrite it as capital X is equal 4 pi. Okay, so continuing from here, I will find my base angle by doing sine inverse of half. This is going to give me an answer in radians of pi over 6. So this is my first angle. And then, as always, I'm going to draw my ASTC quadrants. So x, y. Now I will put my angles in radians. So this is 0. I know that 90 is pi over 2. I know that 180 is pi. And I know that 270 is 3 pi over 2. And I know that 360 is 2 pi. Again, anti-clockwise is positive, clockwise is negative, and I'm going to take a look at what I have here. So what I have is sine of an angle that gives me a positive answer. So I need a positive answer in the sine quadrant. I know that this is A, S, T, C. I know that sine is going to be positive here and here. So let's start with our base angle that we found, which is pi over 6. So I will start the positive x. It's a positive pi over 6, so I'm going to move anti-clockwise pi over 6. And by symmetry, this also should equal pi over 6. To find the next angle, I'm going to also start from the positive x, move all this way. And I know that this straight line is 180 degrees. So if I want this angle, I'm going to do pi minus pi over 6. So the next angle is pi minus pi over 6, which is going to equal 6, which is 5 pi over 6. Okay, let's continue from here. My range, remember, is 0 to 4 pi. Okay, so I can go from here up to the next answer, which is going to be all of this. So a complete rotation, which is 2 pi, plus this part, which is pi over 6. So my next angle is going to be 2 pi plus pi over 6, which is going to be plus pi over 6, which is 13 pi over 6. Okay, let's continue for the angle after this. Let me erase a little bit. Okay, I'll erase this. Okay, so we finished this part. Let's do the next part. Okay, so starting here as well, I'm gonna move all of this, and remember last time was this angle. I'm gonna complete until I touch the next line, which is here. And I know that I did one complete rotation, so it's 2 pi, and then plus this part, this black line, okay? And I know that this black line is basically pi minus pi over 6, or 5 pi over 6. So my answer is going to be, I'll have a full complete rotation, which is 2 pi, plus this extra angle, which is 5 pi over 6. This is going to give me an answer of 17 pi over 6. Right. These are my angles. Am I done here? No, because these are the solution for x. I want the solutions for theta. So let's write the solutions of x. We got x as pi over 6. We got x as 5 pi over 6. And we got a 13 pi over 6. And we got a 17 pi over 6. We know that x equals to theta. So theta equals x over 2. So basically, theta is going to equal these angles divide 2. So pi over 6 divide 2 is pi over 12. 5 pi over 6 divide 2 is 5 pi over 12. 13 pi over 6 divide 2 is 13 pi over 12. And I'll have finally 17 pi over 12. And these are my answers. If you want to check, we can check a random one. Let's say we want a sine. Our question was sine 2 theta equals half. So my theta is 13 pi over 2. So let's try sine times 2 multiply my theta, which is 13 pi over 2. This should give me half if I put it in the calculator. And I would encourage you to do the same. 13 pi over 2. Over 12, sorry. This is over 12. It will give me an answer of half. So I know that my answer is correct. Okay, so for this last part, I'm gonna solve the final question. It's a different style of question, so let's see how we can do it. It has two parts. Part 8 tells me, show that the equation can be written in this form. So I have a 2 sine squared x plus 3 cosine x equals 0, and I want to show that it's in this form. And I notice that this form has cosines only, so I will need to somehow get rid of this sign or convert it to a cosine. And I know from my Pythagorean identities that cosine squared theta plus sine squared theta equals 1. So that makes sine squared theta equals 1 minus cos squared theta. Okay, so I can replace this sine squared theta with 1 minus cosine squared theta. It's going to be something like this. So 2 times, instead of sine squared theta, I'll write 1 minus cosine squared theta plus 3 cosine x equals 0. I'll distribute the 2 is going to be 2 minus 2 cosine squared theta plus 3 cosine. Oh, this is x, this is not theta, sorry. So it's x and x, it's the same thing. So 3 cosine x equals 0. And now I can move this minus 2 cosine to the other side. I'll move everything to the other side, or I'll multiply everything by minus 1. So I'm going to have a 2 cosine squared x minus 3 cosine x minus 2 equals 0. It wants me to find a, b, and c, which are the coefficients. So a must equal 2. My b should equal minus 3. And my c should equal a minus 2. Okay? So this is the solution for part A. Let's move on to part B. So part B says, hence or otherwise solve this equation equals 0 for this range. So again, I'm working with degrees, so I'll make sure that my angle is in degrees. So let's see how we can solve this. So basically this can be written in this form, and I've written it in this form, or the question asked for a reason. So it eases my calculation. So if I look at this equation right here, I'll find something squared minus the same thing, not squared, and then some value or some number. Doesn't this look like ax squared plus bx plus c? So this is basically a quadratic function. Yani if I did something to write it easily, if I let x equals cosine x, or like let's say if I let y equals cosine x, I'm going to have an equation that looks like this: 2y squared minus 3y minus 2 equals 0. And then I can solve this using the quadratic equations. And I've done a complete quadratic series that will show you the multiple ways that you can solve quadratic equations. You can click on the right-hand corner to access those videos. They're very helpful. Okay, so I'll be solving this using let's solve this using factorization. Okay, so I notice that my a is not 1, so I will start by multiplying this a with this c. It's going to give me 4. Next step, I'm going to look at the sign. It's a minus, so I need 2 factors of 4 that subtract to 3, 4, and 1. And since this is a minus, the bigger factor is going to take the middle sign. So 4 is the bigger factor, minus is the middle sign, so it's going to be minus 4 and a plus 1. Rewrite this as 2y squared minus 4y plus y. So this minus 4 is here, this one is basically here, and then minus 2 equals 0. Now I can group and take 2y common from these first two terms. I will have a y minus 2, and then plus I'll have a y minus 2 here, equals 0. I will notice that y minus 2 is common. I can take it out. So y minus 2 taken out of this first term, it will leave me with a 2y. And then y minus 2 taken out of this, which is basically y minus 2 divide y minus 2 is basically a 1, equals 0. So I will know that y minus 2 equals 0. So y equals 2 as my first solution. And 2y plus 1 equals 0. So y equals negative half as my second solution. And I know from earlier that y equals cosine x. So basically cosine x equals 2 and cosine x equals negative half. So I have those two solutions for my equation. So looking at this, I know that my cosine curve looks something like this, starting from 1 to negative 1. So cosine x will never be 2, so I will disregard or discard this answer. And if you try putting shift cosine of 2 in the calculator, it will not give you an answer. So we will not take this, we will focus on this part. So cosine x equals minus half for the range negative 180 degrees equal x to 180 degrees. So let's start again by solving. So we will get our base angle, which is cosine minus 1 of negative half. This is going to give me an answer of shift cosine negative half, a 120 degrees. Again, as always, I will draw my ASTC quadrants: x, y, 0, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. This is anti-clockwise, which is positive. This is clockwise, which is negative. And I will start by looking at my equation. That's the next step. So cosine of something that will give me a negative answer. So I need a negative for a cosine, and I know that this is my ASTC. I know that cosine is negative in the sine quadrant and in the tan quadrant. I will start by doing my first angle, which is 120 degrees from the positive x direction. It's a positive 120, so I'll move anti-clockwise, and this angle is going to be 120 degrees. For my next solution, I'm going to go from here till this next part. I know if this whole thing is 180, then this must be 180 minus 120, which is 60 degrees. And by symmetry, this is also 60 degrees. So to get this second answer, I will need a 180 straight line, and then I will need to add this 60 degrees part to it. So my second answer is going to be 180 plus 60, which is going to give me 240 degrees. Yes. Okay. So moving anti-clockwise to get the next answer, I'm going to exceed my answer, okay? And in fact, I even exceeded it with this second answer. So this 240 degrees is outside of my range, so I will not take it. So for the positive answers, I just have a 120 degrees. Type. My range is not from 0 to 180. I can have some values which are negatives. So let's see how we will do that. Okay, so again, my base angle, so this was 120 degrees, this is 60, this is 60. Okay, I will start here, and then I want to see the negative angles, okay, for this equation. So I'm not gonna move anti-clockwise anymore. I'm gonna start moving clockwise until I hit my first answer. And I know that if this is 60, then this whole thing must be 180 minus 60, which is 120 degrees. And I moved clockwise, so my next answer is negative 120 degrees. So my answers for this question are going to be 120 degrees and a negative 120 degrees. If I tried moving clockwise furthermore to get the next solution, I will find that I will exceed my minus 180 degrees. This is going to be minus 240, so I'm outside of my range, so I will disregard. These are some examples to solve ASTC related trigonometric equations. Please don't forget to like, subscribe, and comment any suggestions or questions you have down below. And thank you for watching. Have a good day.